Introduction.
Anwesha, are you looking at the ship?
Yes, it is such a beautiful sight. See?
You are right. Do you realize that your line of sight forms an angle of 45 degrees with the ground?
You are right, Vedika.
If I told you that the distance between our building and the ship is 10 meters, can you tell me the height of this building?
Yeah, sure. I have learnt my trigonometry well. The answer to your question, that is, height of building is 10 meters.
Anwesha used trigonometry to answer Vedika's question. In this lesson, you will learn about the relationship between angles and sides of a triangle. Objectives. At the end of this lesson, you'll be able to define trigonometric ratios of angles, calculate trigonometric ratios of specific angles, compute trigonometric ratios of complementary angles. Origins of trigonometry. The word trigonometry derives from two Greek words, trigon, meaning triangle, and metria, meaning measurement. Thus, trigonometry represents a branch of mathematics that examines the relationship between the sides and angles of a triangle. The Egyptians and Babylonians were the first to use trigonometry for astronomical studies. The Greek astronomer and mathematician Hipparchus compiled the first trigonometric table. That is why he is considered the father of trigonometry. Trigonometric ratios. Let us begin our introduction to trigonometry with trigonometric ratios. We will express the angles as trigonometric ratios, compare trigonometric ratios of similar triangles, and solve examples. Angles as trigonometric ratios. Look at triangle XYZ. Right-angled at Y. Angles X and Z are both acute. XY is the side opposite to angle Z. YZ is the side adjacent to angle Z. XZ is the hypotenuse. Let us now express different measures of angle Z as ratios of the sides of triangle XYZ. Sine of angle Z is equal to sine Z, which equals opposite side upon hypotenuse. Cosine of angle Z is equal to cos Z, which equals adjacent side upon hypotenuse. Tangent of angle Z is equal to tan Z, which is equal to opposite side upon adjacent side. Cosecant of angle Z is equal to cosec Z equals 1 upon sine Z equals hypotenuse upon opposite side. Secant of angle Z is equal to sec Z equals 1 upon cos Z equals to hypotenuse upon adjacent side. Cotangent of angle Z is equal to cot Z equals 1 upon tan Z equals adjacent side upon opposite side. Greek letter theta is used to represent an angle. Therefore, sine Z may be written as sine theta. Similarly, cos Z is equal to cos theta, tan Z is equal to tan theta, cosec Z is equal to cosec theta, sec Z is equal to sec theta, and cot Z is equal to cot theta. Trigonometric ratios of similar triangles. Consider the two triangles, triangle ABC and triangle DEF. Angle A is equal to angle D. Angle B is equal to angle E. Angle C is equal to angle F. Hence, triangle ABC is similar to triangle DEF by AAA criterion of similarity of triangles. Therefore, the corresponding sides of the two triangles are proportional. Thus, it is clear that trigonometric ratios do not change with changes in the sides of a triangle as long as the angles remain unchanged. Examples. Let us look at some examples to consolidate our understanding of trigonometric ratios. It is given that triangles ABC, right angle assessment. Look at the given triangle carefully. Drag and drop the options in the appropriate boxes. Trigonometric ratios of specific angles. Having understood trigonometric ratios, let us now compute trigonometric ratio of 30 degree, trigonometric ratio of 60 degree, trigonometric ratio of 45 degree, trigonometric ratio of 0 degree, trigonometric ratio of 90 degree, trigonometric ratio of 30 degree. Consider the equilateral triangle XYZ. XY is equal to YZ, which is equal to XZ, which equals S. Angle X is equal to angle Y, which equals angle Z. Let us now draw a perpendicular from vertex X to intersect side YZ at T. In triangles XYT and XZT, XT is equal to XT, common side. XY is equal to XZ, given. Angle XTY is equal to angle XTZ, right angles. Therefore, triangles XYZ and XTZ are congruent by RHS congruence. Therefore, angle YXT is equal to angle ZXT, which is 30 degree. YT is equal to ZT, which is 1 upon 2S. According to Pythagoras theorem, in triangle XYT, XT square plus YT square is equal to XY square. By substituting the values, we get XT square plus 1 upon 2 S whole square equals S square. Now, by calculating it, we get XT is equal to square root 3 upon 4 S square is equal to square root 3 upon 2S. Sine 30 degree is equal to YT upon XY equals 1 upon 2S upon S is equal to 1 upon 2. Cos 30 degree is equal to XT upon XY, which equals square root 3 upon 2S upon S equals square root 3 upon 2. Tan 30 degree is equal to YT upon XT equals 1 upon 2S upon square root 3 upon 2S equals 1 upon square root 3. Trigonometric ratio of 60 degree. Consider the same equilateral triangle XYZ. Recall that XY is equal to YZ, which equals XZ, which is equal to S. Angle X is equal to angle Y equals angle Z. XT is a perpendicular from vertex X, which intersects side YZ at T. Triangles XYZ and XTZ are congruent. Therefore, YT is equal to ZT equals 1 upon 2S. According to Pythagoras theorem, XT square plus YT square is equal to XY square. By substituting the values, we get XT square plus 1 upon 2S whole square is equal to S square. By calculating it, we get XT is equal to square root 3 upon 4S square, which is square root 3 upon 2S. Sine 60 degree is equal to XT upon XY, which equals square root 3 upon 2S upon S equals square root 3 upon 2. Cos 60 degree is equal to YT upon XY equals 1 upon 2S upon S equals 1 upon 2. Tan 60 degree is equal to XT upon YT equals square root 3 upon 2S upon 1 upon 2S equals square root 3. Trigonometric ratio of 45 degree. Consider the right-angled isosceles triangle XYZ. XY is equal to YZ, which equals S. Angle Y is equal to 90 degree. Angle X is equal to angle Z, which is 45 degree. According to Pythagoras theorem, XY square plus YZ square is equal to XZ square. By substituting the values, we get S square plus S square is equal to XZ square. XZ square is equal to 2S square, which is XZ is equal to square root 2S. Sine Z is equal to sine 45 degree, which equals XY upon XZ, which equals S upon square root 2S, which is equal to 1 upon square root 2. Cos Z is equal to cos 45 degree, which equals YZ upon xz is equal to s upon square root 2s is equal to 1 upon square root 2. Tan z is equal to tan 45 degree, which equals xy upon yz, which equals s upon s, which is equal to 1. Recall the discussion of Vedika and Anwesha at the beginning of the lesson. Height of building upon distance between building and ship is equal to tan 45 degree. By substituting the values, we get height of building upon 10 meters, which equals 1. Therefore, height of building is equal to 10 meters. Trigonometric ratio of 0 degree. Consider the right-angled triangle XYZ. Reduce the measure of angle Z slowly. You can see that XZ rotates left and becomes flatter. When the measure of angle Z is reduced to 0 degree, XZ merges with YZ and the length of XY is 0. Let us understand what happens to the values of trigonometric ratios. Sin Z is equal to sin 0 degree, which is equal to XY upon XZ, which equals 0 upon XZ, which is equal to 0. Cos Z is equal to cos 0 degree, which equals YZ upon XZ, which equals 1, as YZ is equal to XZ. Tan Z is equal to tan 0 degree, which equals XY upon YZ equals 0 upon YZ is equal to 0. Trigonometric ratio of 90 degree. Consider the right-angled triangle XYZ. Increase the measure of angle Z slowly. You can see that XZ rotates right and becomes steeper. When the measure of angle Z is increased to 90 degree, XZ merges with XY and the length of YZ is 0. Let us understand what happens to the values of trigonometric ratios. Sin Z is equal to sin 90 degree, which equals XY upon XZ, which equals 1, as XY is equal to XZ. Cos Z is equal to cos 90 degree, which equals YZ upon XZ, is equal to 0 upon XZ, which equals 0. Tan Z is equal to tan 90 degree, which is equal to XY upon YZ equals XY upon 0. Therefore, tan 90 degree is undefined. Let us summarize our exercise in a table. Assessment. Match the trigonometric expressions on the left with their values on the right. Trigonometric ratios of complementary angles. Two angles are said to be complementary if the sum of their measures equals 90 degree. Consider the triangle XYZ, right-angled at Y. Angle X plus angle Y plus angle Z is equal to 180 degree. Angle Y is equal to 90 degree. Angle X plus angle Z is equal to 180 degree minus 90 degree equals 90 degree, which implies angle X is equal to 90 degree minus angle Z. Or simply, X is equal to 90 degree minus Z. Let us first list the trigonometric ratios of angle Z. Sin Z is equal to XY upon XZ. Cos Z is equal to YZ upon XZ. Tan Z is equal to XY upon YZ. Cosec Z is equal to 1 upon sin Z equals XZ upon XY. Sec Z is equal to 1 upon cos Z equals XZ upon YZ. Cot Z is equal to 1 upon tan Z equals YZ upon XY. Let us now list the trigonometric ratios of angle X. Sin X is equal to sin 90 degree minus Z equals YZ upon XZ equals cos Z. Cos X is equal to cos 90 degree minus Z equals XY upon XZ is equal to sin Z. tan x is equal to tan 90 degree minus z equals yz upon xy equals cot z. Cosec x is equal to cosec 90 degree minus z equals xz upon yz equals sec z. Sec x is equal to sec 90 degree minus z equals xz upon xy equals cosec z. Cot x is equal to cot 90 degree minus z equals xy upon yz equals tan z. Let us first compile our observation and then use it to solve questions. Sine 90 degree minus z is equal to cos z. Cos 90 degree minus z is equal to sin z. Tan 90 degree minus z is equal to cot z. Cosec 90 degree minus z is equal to sec z. Sec 90 degree minus z is equal to cosec z. Cot 90 degree minus z is equal to tan z. Solve sec 21 degree, cosec 79 degree. Sec 21 degree is equal to cosec 90 degree minus 21 degree equals cosec 79 degree. Therefore, assessment. Match the trigonometric expressions on the left with their corresponding values on the right. Did you know? Trigonometry is used to calculate the distance between celestial bodies and the height of tides in oceans. Is a popular mnemonic used to remember trigonometric ratios. It means sine opposite upon hypotenuse, cos adjacent upon hypotenuse, and tan opposite upon adjacent. The word cosine sounds similar to its Sanskrit counterpart, kotijya, used by Aryabhatta. The word sine derives from the Latin translation sinus of jiva or jya, used by Aryabhatta to denote half-chord. Summary. Let us summarize what we have learned. Trigonometric ratios of acute angles in a right-angled triangle. Trigonometric ratios of specific angles such as 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree. Trigonometric ratios of complementary angles.